Okay, so we're going to talk about what happens if the degree of the numerator is larger. Okay. Yesterday we talked about, specifically, we looked at if the degree of the numerator and denominator are the same, or the degree of the denominator is bigger. So if the degree of them is the same, then we just take and simplify that. Take the leading coefficient of each one and simplify that fraction. If the degree of the denominator is bigger, which we had in letter B, then the horizontal asymptote is y equals 0 for the end behavior. But if we end up with a situation where the degree of the numerator is larger, then we have a whole nother situation. Last year we said, or in Algebra C, we said that if the degree of the numerator is larger, then there is no horizontal asymptote. That's all we cared about then. Okay? Now we care about complete end behavior. What happens to any rational function as x gets really big or really small? And so if the degree of the numerator is larger than the denominator, then we've got some work to do. And so we're going to end up doing, I don't think we need to do number 7. We've done enough of them, so we need to do number 8 then, one where it's bigger. And maybe we'll go take a look at number 22. Okay? So graphing rational functions. So analyze the function, algebraically determine its vertical asymptotes, holes, and intercepts. Okay, we did that. Determine the end behavior. So we need to look at the degree of the numerator and denominator there, and then use your specific information and a good viewing window to make it. So let's look at number 8 then. And I'm going to get rid of 7 here. Oops, no I'm not. It's connected. I'll do something else. Gone. Okay, so first thing we need to do is factor it if we can. Okay? Can we factor x cubed minus x squared minus 10x minus 8? Can you do what? Okay, that would be a good thing to try. All right, can I factor it by grouping because I have 4 terms? And lots of times with 4 terms I can factor by grouping. And in this case I have x squared times x minus 1, but I wouldn't get x minus 1 the other part, would I? All right, so you're going to have to get your calculator out to find the zeros for the numerator. Just the numerator. So if you want to go with your table, go with the graph, use the app, whatever it takes, we want to factor the numerator first. Now we're going to factor it. Okay? And in this case, because of the cubic, it doesn't matter how you go about doing that. But we are finding the zeros, but we're actually going to do that by factoring first of all. And these all should be integers. So who's got them? Nathan, you got them? I want just, tell me the zeros and I'll write it in factored form.
-2, -1, and 4.
Okay. All right, so this means I have x plus 2, x plus 1, and x minus 4, right? Okay, so what's the first issue I have? Okay, I have the same factor in the numerator and denominator. So that tells me I have a hole at 4. All right, so that can't be a 0 then, can it? All right. All right, so vertical asymptotes. Where do I have vertical asymptotes at? at x equals, where's the denominator equal to 0? At 3. Do I have one at 4 also? No, because we can't have a 0 and a vertical asymptote. That's why we have the hole there at 4. Okay? So now the thing I don't know is my end behavior. All right? I don't know what happens as x gets really large or really small. So we need to look at this more closely. Right? So the numerator, if I take the first term of each one, we've got x cubed over x squared. When I simplify that, I get x, right? Okay. All right. That's a line, isn't it? Okay, it's on a diagonal kind of. All right. So whenever the degree of the numerator is larger than the denominator, okay, if it's one larger, you have what's called a slant or oblique asymptote. Okay, it's going to be a line. If it's two larger, we're going to have what's called a parabolic asymptote because the end behavior is going to behave like a parabola. Okay? So how do I know what that asymptote is? And this is where we get to do some of those fun things we've been doing called division. Either long division or hopefully synthetic division works. Now in this case, what you can do is we are in a good position because we have a common factor here. So I don't need to use these two. Those are canceled, they're gone. Okay? So all I need to be able to find that end behavior then is the fact that I have x plus 2, x plus 1 over x minus 3. So I've got to do either long division or synthetic division with those two and do my dividing so that I can find the exact value of this asymptote. So let's see, my numerator, x squared plus 3x plus 1, right? Or plus 2, excuse me. Okay. And the denominator is x minus 3. Well, do you want to do long division or synthetic division? All right, synthetic is easier because we have a linear that we're dividing by, where the coefficient is 1. So we take 3, 1, 3, and 2. All right, this is the easy one. Okay. Bring down our 1, get 3 here, get 6, and 18, so this is 20. All right, now, you see this thing right here on the end? What do we call that? Okay, the remainder. When it comes to asymptotes, we don't care. Okay? So the end behavior for this function, this rational function, is y equals x plus 6. Because I have 1x plus 6 down here. Okay, now, the graph of this then. Much more difficult. Not really. Okay, it's really not. Okay, so put it in your y equals as it is. The original function. Put it in your y equals. And we're going to talk about seeing all this information. All right, so here's our graph with our standard viewing window. That's interesting. Okay. Now, what's the problem? That's only part of it, okay? Because I know there's got to be a graph on each side of the asymptote, okay? There's a vertical asymptote at x equals 3, right? So I could draw a vertical line here at x equals 3. Now, if it goes down on one side of the asymptote, it has to go up on the other side. Well, we can't see that, can we? Right? So what do I need to do? Okay, I need to change my window. All right, so we'll go and we'll... Now, I can actually trace here to help myself out. So if I hit trace and type in some number down over here, let's say 5, for instance, okay, something to the right of my asymptote, I get 21. Wow, I have no idea what it just did. Hey, look at that. I wonder what I did to make it do that. I must have hit enter twice, yeah, and it did it. So, okay, so we can see that it's there. So I need to take my window and stay with my standard viewing window, negative 10 to 10. But my Y min still negative 10. Y max, let's go to 25. Okay, didn't like what I just did. Smarter than I thought it was then. All right, here we go. All right. So now we can see both parts of the graph. All right. Now, so here's the thing. I actually need to make this bigger because I want to show you what happens. So I'm going to go bigger with it both directions. So I'm going to go negative 20 to 20 and negative 10 should be fine there. And I'm going to go to 40 here. Hope that's big enough. Should be. Yeah, it will. Okay. Now, there's my graph. Now go to Y2. What was my asymptote I got for the end behavior? X plus 6, right? Okay, so I'm going to put in Y2, I'm going to put X plus 6. All right, and watch what happens. Okay, so that does represent my asymptote. And if I made it even bigger, and you guys like to do this, I don't, but I'm going to do it for in this case. Zoom out. If we zoom out, then it's even going to look better because we'll see that even farther away from the x-axis, or from the y-axis, it's even closer to the line y equals x plus 6. Okay. So if the degree of the numerator is 1 larger, you're going to have what's called the oblique or slant asymptote. It's just going to be some line y equals x plus something. So you do long division or synthetic division to find that, and we don't care about the remainder. Okay, the remainder has no effect on it at all. Okay, so that's a fun graph. Now, one thing is though, is we said we had a hole somewhere, right? Where was it at? All right, hole's at 4, so if I hit trace, put in 4 and enter, we get nothing. How do I know where that hole is exactly? Right, but where do I know it's an exact point? There's a hole, this hole is an exact point. Where is it exactly? So if I wanted to graph it myself, where would I put that hole at? Thank you very much. It's not on the line x plus 6. Well, what's the x value for the whole?
4.
4. So how would I find the y value for the whole? Put it in.
All
right.
X is 0.
Now, I'm not going to put it in here in the original because then I would just get undefined because it'd be 0 over 0, indeterminate form. But if I put it in here after I've simplified it, I can find it for sure. So we get 4 plus 2, 4 plus 1 over 4 minus 3. So 6 times 3 is, 6 times 5 is what? 30 over 1. So the whole is specifically at the point 430. Okay, let me see if I agree with that or not. Okay. Let's find out. All right. So if I hit trace, if I did that, so if I go just to the right, oh, that's not right. What did I get? I messed up something.
Oh, wait. It says... Because it says at 4 there's an error, so...
Right, but let's go to our window, our graph and table. Okay, oh, that is, I'm sure that is the case then. All right, so the hole would be at the point 430. So if you drew the hole in, you'd have to put an open dot at the point 430, okay, to show where that hole is. All right, now let's look at number, what was it, number 20, right?
Those are weird, like...
All right, so once again, we have a cubic function in the numerator. All right, so we're going to have to graph it to find the zeros. But let's do that first then, okay? Find the zeros for the numerator.
I don't even know how to do this part. Not. Where does that count?
Yeah, that's one.
Oh, it's too...
Okay, so the only zero is at negative 0.578, right? How many of you got that? Nobody? All right, a couple people did. All right, you're not alone, Clara.
Okay.
Okay, so we have a vertical asymptote at x equals 2, and then our end behavior then, okay, is gonna, what happens as x gets really, really big? So for the end behavior, I'm going to take these two terms, and when I look at them, what do I get when I do x cubed over x? You get x squared. So in this situation, it's going to be a parabolic asymptote. Okay? The asymptote is going to behave like a quadratic. So we need to find out what it is. So we need to divide again. So we'll divide using our synthetic division again, since they're being nice to us.
Like, better be nice, that's what they gave us the most annoying zero.
So we do the synthetic division. All right? And once again, we do not care about the remainder. Okay? So our end behavior then is the line y equals x squared minus 2x plus 2. It's a quadratic function. Now, that's not the behavior of it right at the x-axis. That's the behavior of it as we're moving away from the y-axis, why we're moving away from the y-axis. All right. So graph the function. All right, and then my other graph in y2, I'm going to put x squared minus 2x plus 2. And I can even use that nasty window I didn't like in the last one. And here's my function. And here comes my asymptote eventually. All right, oh, that's even too big. So let's go negative 20 to 20. Should work. All right, so there we can see where our vertical asymptote is. And then here comes the parabolic asymptote then. We can see that the behavior of it is a quadratic then as it gets farther and farther away from 0, the y-axis. What's that?
Put your graph at.
It's negative 20 to 20 and, I don't know, negative 85 to 115.
Wait, how can you show those numbers?
I didn't. I hit zoom out on the last one. That's where it went. And I just shortened up my x-axis. Okay, questions?